Welcome back, everyone. Today I'm going to show you how to make two shapes, both of which are made very similarly, a cube and a dodecahedron, using these interesting hyperboloid subunits. So what I have here is everything I'm going to need for the cube. What I have over here is everything I'm going to need for the dodecahedron. Let's start with the cube because it's the smaller one. What you'll need are 6 of these hyperboloids. These ones have 4-sided symmetry. The way you make them is by starting with a double chain like this here. You take 4 and then attach the chain here. So you have this, pinch off here, add another layer there. Do it again like that. Then attach here, and you get this subunit. Notice there are 4 peaks there. Then this can be curled up and attached to itself, and that's how you get these. Again, you need 6 of them. You also need 12 of these subunits here. These are just 5 by 4 rectangles. You take these double chains again, you take a length of 5, and you take another length of 5 and attach them together just like this. The 5 by 4 length is a little uncooperative. It always kind of splits down a diagonal like that. That is okay. We'll fix that when we're attaching it. Finally, you need some rings of 9. You need 8 rings of 9. I just have them in a tube right now, but they'll be individual later. For the dodecahedron, you'll need 12 of these slightly larger hyperboloids. These have 5-sided symmetry. These are made exactly the same way as the ones for the cube with 4-sided symmetry, except they have an extra peak. So they're made with a few extra magnets. So they look like this. They have 5 peaks instead of 4. Again, it gets curled up on itself, and you end up with one of these. In the case of the dodecahedron, you need 12 of those, and then you need 30 of these. These are 4 by 4, so they attach together relatively easily and nicely. They don't split apart or anything. Pretty straightforward in that case. You need 30 of those, and then in this case, you'll need 20 rings of 9. So now that we know all the subunits, to start with, for the cube, you take all 6 of these and attach them together. Each side will go like that. And we'll do a third one here. Add another one. And another one. And the last one. And you get a shape that looks like this. Next, what you need to do is take these 5 by 4 rectangles here and attach them to where one rectangle goes in between 2 of these hyperboloid subunits. You're using the end with a length of 5, and you kind of have to mash it down to where it gets in your fingers and stays approximately rectangular while you're doing this. Difficult to show on camera. One end will attach just like that, and then the other end will attach up here just like that. Now you'll have these little holes that open up, and you can just kind of carefully push them back together until what you have is a nice little bridge that looks like that. Go ahead and do that to all 12 spaces between each of these. Okay, and once you've attached all of those 5x4 rectangles, you should have a shape that looks like this. All you need to do now is cut up these 8 rings of 9 into single rings. And then on each of these corners, place a ring right here. Oh, I have the polarity backwards, so just flip it upside down if that happens. And it should snap right down in, just like that. You can actually take 3 magnets and put them here to really make the corners square, but I really like the reflections you can get by looking in here. I don't know if the lighting here is going to be appropriate to where you can really see them, but you'll see them in the photos that I include at the end. Go ahead and add all 8 of these triangles on. And there you go. This is the shape that I'm calling the hyperboloid cube. Moving on to the dodecahedron, you take all 12 of these 5-sided hyperboloids and attach them together in a very similar way to what you did for the cube. Just like that there. The difference is these being 5-sided, it takes 12 of them instead of 6, and the final shape that is formed ends up being a dodecahedron instead of a cube. And once you've attached all 12 of them together, you should have a really interesting looking shape like this with dodecahedral symmetry. From here, it's again a very similar process to what you did with the cube. These 4x4 squares just bridge directly between each of the 12 pentagonal hyperboloids. And these are much, much simpler to attach compared to the cube. This is very, very hassle-free compared to what that one was. These just attach immediately without a whole lot of messing around with them required. One thing I would like to note though is that the base shape here underneath, until you get 5 of them attached in a ring like that, it's very fragile. I would advise against putting it down on a flat surface until you have 5 of them done, and then you can set it down on those 5 like that. Now go ahead and complete the rest of the 20, or 30, sorry. Okay, at this point you'll have a shape that looks like this. Again, similarly to before, you just take these 20 rings of 9 and cut them all up into single rings. In this case, I find that it does help to pinch each of these into a triangle like that before you put it on. The other one not so much, but for this one it helps. And then finally, you attach these down into these holes just the same way as you did before, making sure that they stack, not interlink. just like that. And that's it. You're pretty much done with this shape. One finishing touch I like to put on it, and I don't know how clear this is going to be on camera, but we'll give it a shot, is that because these corners were pinched into triangles, you can still see that triangle relatively clearly on the surface. Now if you take something long and thin, I'm using one of these prototype Zen Magnet tools that they're giving out to some of the gallery members. If you just split the magnets in each corner apart, and you get a corner that looks like that instead of that, I think that looks nicer than that. And yeah, it shows up reasonably well on camera. So go ahead and repeat that process on all 20 corners, and then you'll be done. And there you go. Now it is finally complete. And here we have the Hyperboloid dodecahedron and cube. Now, as I mentioned earlier, you can put 3 magnets on these corners here to really give it a more sharp appearance, but there are these really nice reflections that you get by looking right down into the corner here, and they're also visible on this one as well. Again, not really sure how well this is going to show up on camera, but give it a shot there. So I like to leave those corners open.